Hi everyone, today topic is type of solar cell material. Introduction. Solar cells are the devices that convert sunlight into electricity. There are several types of solar cell materials, each with its own unique characteristic. Here are some of the commonly used solar cell materials. It is monocrystalline silicon. Monocrystalline silicon is made from a single crystal structure and it has a high efficiency and it is one of the mostly widely used material for a solar cell due to its excellent electrical properties. Monocrystalline silicon is the base material for the silicon-based discrete components and the integrated circuits used in virtually all modern electronic equipment. Monocrystalline silicon is also serves as a photovoltaic and a light-absorbing material in the manufacture of solar cells. Polycrystalline silicon. Polycrystalline silicon is made from the multiple crystal structures and it is less expensive to produce compared to monocrystalline silicon. It has slightly lower efficiency, but it is still commonly used in solar panels. This is about the polycrystalline silicon, and this is the difference between polycrystalline silicon and monocrystalline silicon and how the structure is there. And thin film solar cells. Thin film solar cells are made by depositing one or more thin layers of photovoltaic material onto substrate such as glass, plastic, or metal. Thin film solar cells are typically a few nanometers to a few microns thick, much thinner than the wafer used in conventional crystalline silicon based solar cells, which can be up to 200 microns thick, and thin film solar cells are commonly used in several technologies including cadmium telluride and copper indium gallium diselenide and amorphous thin film silicon. Some common type of thin film solar cells include amorphous silicon, cadmium telluride and copper indium gallium selenide and organic photovoltaic cells. Amorphous silicon has lower efficiency compared to the crystalline silicon, but it can be deposited on flexible substrate, making it suitable for applications such as building integrated photovoltaics. And amorphous silicon is the non-crystalline form of silicon used for a solar cells and thin film transistors in LCDs and used as a semiconductor materials for a silicon solar cell or thin film silicon solar cell, and it is deposited in thin films onto a variety of flexible substrate such as glass, metal, and plastic. Cadmium telluride, that is CDTE. CDTE is a compound semiconductor that has gained popularity due to its high absorption coefficient and low manufacturing costs. CDTE is a stable crystalline compound formed from a cadmium and tellurium. It is mainly used as the semiconducting material in cadmium telluride and photovoltaics and an infrared optical window, and it is usually sandwiched with cadmium sulfide to form a PN junction solar PV cells. Copper indium gallium selenide, that is CIGS. CIGS solar cells offer good efficiency and can be fabricated on variety of substances. They have the potential for flexible and lightweight solar panels. Copper indium gallium selenides, that is CIGS, is a first, third, or sixth semiconductor material composed of copper, indium, gallium, and selenium. The material is a solid solution of a copper indium selenide, that is often abbreviated abbreviated CIS, and copper gallium selenide. It has a chemical formula of CuIn1, where the value of X can vary from 0 to 1, and CIGS is a tetrahedrally bonded semiconductor with the Chal copyright crystalline structure and a band gap varying continuously with X from about 1.0 electrovolt to about 1.7 electrovolt, from about 1.0 electrovolt to 1.7 electrovolt. Organic photovoltaic, that is OPV cells. OPV solar cells aim to provide an earth abundant and low energy production photovoltaic solution. This technology has also theoretically potential to provide electricity at a lower cost than first and second generation solar technologies. Organic photovoltaic solar cells, that is OPV, aim to provide an earth abundant low energy production photovoltaic, that is PV solution. This technology also has the theoretical potential to provide electricity at a lower cost than first and second generation solar technologies. Let's see about the multi-junction solar cells. Multi-junction solar cells consist of a multiple layer of a different semiconductors that observe different portion of a solar spectrum. This allows for higher efficiency by capturing a broader range of sunlight. Multi-junction cells are often used in space applications and concentrated photovoltaics. And multi-junction solar cells consist of a multi-layers of a different semiconductor that observes the and conclusions. These are some of the most common type of a solar cell material used in the industry. Each material has its own advantages and limitation, and ongoing research aim to develop new materials with improved efficiency and cost effectiveness.